Hello everybody, myself Jyoti and this is sixth lecture on physics of semiconductors and today's topic is conductivity of extrinsic semiconductors. So we know that the conductivity of semiconductors it is more complicated than that of the metals because the besides the electron scattering process being temperature dependent as in the case of metal, in case of semiconductors, actual number of charge carriers and their energy distribution that is also temperature dependent. In case of metals, only electron scattering process is temperature dependent. But in case of semiconductors, electron scattering process it is temperature dependent, number of charge carriers is temperature dependent and energy distribution of these charge carriers it is also temperature dependent. So that is how when we have to explain the conductivity of semiconductor it is more complicated as compared to metals. Now we know that resistivity it is given by 1 by sigma, that is 1 upon Ne mu. So log rho is equals to log of 1 upon Ne mu. I have just taken log on both the sides. Now whether mobility it is temperature dependent or not. Now if you look at this equation, 1 by sigma equals to 1 upon Ne mu. So I can find out the value of mu. Mu will be 1 upon Ne, mu it will be equals to sigma upon Ne. So looking at this equation, we find that mobility is not temperature dependent, but it is not like that. The mobility is assumed to be independent of temperature in this equation, but this is not true. Mobility is determined by scattering of the current carrying particles, and current carrying particles are temperature dependent. So naturally, mobility that is also temperature dependent. Now, when we talk about the mechanism of scattering, there are two types of the scattering is because of lattice and impurity. So, one mechanism by which scattering occurs, it is because of the lattice vibration or vibration of the lattice atoms about their mean position. This type of scattering it is called as lattice scattering. Other way in which charges are deflected or they get scattered is by interaction with impurity atoms. Because when we are considering n type or p type semiconductor we are doping certain foreign atoms, or even if we are not doping, like we are talking about extrinsic semiconductor over here, so naturally we are either doping aluminum or phosphorus, either we have a p type or n type. So these impurity atoms they also like produce scattering, and that is called as impurity scattering. Now what is the role of this scattering, or what is the effect of this scattering? So both impurity and lattice scattering lower the mobility of charge carriers, and as the mobility of charge carriers will be decreased, and hence that material will have a higher value of resistivity, or you can say less conductivity. So why resistivity of a metal increases with increasing temperature? When you take metal, the density of current carriers is the density of electrons, because in metals we have electrons as the charge carriers. Now this number of electrons it is substantially constant, and any variation of resistivity in a metal with temperature is due to mobility variation. Now if you take most metals, the main type of scattering which is happening in case of metals, that is lattice scattering. And this lattice scattering it increases with increase in temperature, because as I will increase the temperature, atoms will start vibrating about their mean positions more, because when temperature is more, thermal energy which is given by E equals to kT, that associated with that particular atom it will be more, and hence as there will be more lattice vibration, scattering will be more. As the scattering will be more, mobility will decrease, and as mobility will decrease, resistivity of a metal increases with increasing temperature, or you can say conductivity decreases. Now if you take the example of semiconductor, it is just opposite. So why it is so? So we know that resistivity it is given by rho equals to 1 upon Ne mu. That means in a metal, um, the resistivity depends upon the mobility, because n is constant, E is constant, and rho it increases with temperature because of the mobility variation. In a semiconductor, however, n increases with temperature. because in semiconductor we know that the number of charge carriers, they go on increasing with respect to temperature, and this increase in charge carrier, that is increase in n, it is faster as compared to the decrease of mobility because of the temperature, and hence resistivity decreases with increasing temperature. Now here when you plot the graph of log of conductivity versus reciprocal of the temperature, you get such kind of a graph. Now here we can divide the graph into three regions. One is this region A, another is region B, another is region C. Now what is happening in region A? Region A, here we get the conductivity because of the impurity atoms. So when the temperature is less, as the temperature goes on increasing, then suppose the temperature is greater than 0 Kelvin but it is less than 200 Kelvin. In between, what happens between 0K and 200K? Whatever impurity atoms are there, they start conducting. So in region A, we are getting increase in conductivity, that is because of the impurity atoms. Now as you will increase the temperature more, like you can say between 200 Kelvin to 300 Kelvin, then by that time most of the atoms, they go from the, like, they've already the conduction because of the impurity atoms, that is already completed, and some of the electrons, they may jump from valence band to conduction band, and that current is almost constant. So the current which we get because of the jumping of electron from valence band to conduction band, that is almost constant, and that is the region B. Now, what is happening in region C when you increase the temperature further? What happens is conductivity goes on increasing. Here, when the temperature is increased further, in the sense by that time there is no role of impure metals, and here the conductivity increases because breaking of covalent bonds will take place, and here the semiconductor, it behaves like a pure or intrinsic semiconductor. So that is region C. So yeah, again we will see what is happening in region A. In region A, the impurity atoms alone are ionized, and therefore conductivity is less. As the temperature is increasing, number of atoms ionized will be increasing and conductivity increases. This slow increase in conductivity is due to large impurity scattering and small amount of carriers. Usually the impurities are completely ionized at 200 Kelvin. And the slope of the log of conductivity versus 1 by T in the region A, that is what we call as a ionization energy of the impurity. In region B, there is no increase in conductivity due to the impurity conduction, and the temperature is high enough. In region B, the temperature is high enough to allow many atoms to jump directly from valence band to conduction band, and hence conductivity remains relatively constant. And in region C, what is happening is the temperature is high enough to allow carriers arising from valence band to go to the conduction band, and band generation to dominate, and the semiconductor behaves as an intrinsic material. So in region C, there is no conduction because of the impurity atoms. It is mostly because of the intrinsic nature of that material only, because most of the electrons, they are going from valence band to the conduction band. And the slope of the curve in the region C can be related to what we call as a energy gap E, because here whatever conduction we are getting, it is because of the jumping of electron from conduct valence band to conduction band. So that difference of energy, it is nothing but energy gap. And the onset of C in germanium is 150 degrees Celsius, while for silicon it is about 250 degrees Celsius. So that is about it. Thank you so much.